Hello. We're going to make a tutorial on how to use TurboStruct in a very basic way. So here, the first thing we're going to do, obviously, is go to Fab and download it, just like any other plugin. It doesn't show up for me because it's not uploaded yet, it's not published. But once it is published, it will appear for me too. Okay, once we've downloaded the plugin, we'll go to settings and then to plugins. Here, we activate it like any other plugin. We can find it here in the plugins or search for it up here. We activate it, then click restart down below and we'll already have the plugin. Alright, to begin with, what we're going to do now is I'll demonstrate a few examples of how to use the plugin. The first thing is this. This is a basic save and a basic load function. So what exactly do we have here? We have this particular node, which is the main one that you can search for within any blueprint, specifically the TurboStruct save. This one right here, which we can clearly see has several different things. First of all, it has name of the save file parit a subslot because internally each file has subslots to store different things. For example, in subslot 0 we can save the inventory. In slot 1 we can save the world state. In slot 3 we can save the state of the NPCs, and all of this is done within one single subslot. Afterwards we tell it if we want it to be asynchronous or an asynchronous save. What this will change is that it will prevent us from having hitches, meaning the game won't freeze on us during the save process. Then we pass the data. Here I have some data. I have a structure that I've connected to it, which is this one right here, player save. Let's assign some random values, for instance, 100 health points, 50 mana points, the name Alejo, and the position, just like that, any number at all. Here in Isea data node, we can connect whatever we want. We're not tied to this structure. We can connect any structure or any simple data. For example, we can connect an integer here if we want, and it will save it. But anyway, we'll leave the player save connected for the example. Let's save and compile. Alright, and here's an event that will execute coming from here from uncompleted. We can get this event like this, a custom event, and it appears. Okay, this event comes with a series of data points, whether the save was completed successfully or not. The file path, which is this one here, is the same as what we put in main slot name, and the subslot we put here, in which subslot it was saved. Now, we're going to see why, because in some of the next examples, we'll see we can create a lot of saves. To do that, we need to know what the subslot is. Well, basically, we now have the information here, and here we have the event. And with one, I'll execute it. Let's hit play. Okay, I'm going to click on one here, and we see here it says saved in slot 0. So it tells us that this was saved in slot 0. Alright, right here below, we have the function for loading or load. Here we can see that we have the player variable along with its data. This one is currently empty because it's the player load variable. Over here, we have player save, which is the one we just stored, and player load, which is the one that's currently empty. Well, as we can observe here, within the data, the variable is completely empty. Now I'll come here, I'll press 2. The little sign popped up, loading slot 0. And when I put the mouse here, as we can see, it already says name Alejo, health 100, mana 50. This is obviously because it was saved, right? If I click exit once more, it will be back to 0. And if you press play and then 2, you'll see it has the values we had saved. Inside a saved game, a folder will be created with our save files, and inside we'll see the file created. Example 1, which is what we entered here, the same name, and it weighs 600 bytes. Well, that's all for the first example. Now, let's move on to the second example. So, here's example 2. Demonstrating queue usage in TurboStruct. For that, we'll use the same save function. Here we'll change its name, and this variable, which contains many different data types, all supported by TurboStruct. Here, We see that bool, byte, integer 64, blah, 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 another structure, set map. What is the other structure? Well, this one here is something that stores an integer. But anyway, what we're going to do here is come and say, perfect, we're going to put it into a loop that goes from 0 to 100. That is from 0 to 99. So it will execute 100 times, and that will be the subslot where we're going to store the data. Here we have a function to assign random values to this. So with each loop execution, we'll have different values to store. Here, sa ating the function is for that simply. And here, well, we have the save event. It tells us when it finished and says it was saved in slot X. We are going to come here, we'll hit play, and when we press 3, we see that everything executed here. If we look at the order, we'll see it starts at 0, 1, to 3, and as we saw, they weren't all executed at once. Each time one finished, the next one would be executed. That's where the concept of a queue comes from. The first one in, the first one out. Okay, this here in the files will create this file which weighs 278 kilobytes. Why does it weigh so much more than the previous one? And because the previous file, what it saved for us were just 3 variables. Here we are storing 99 times this thing right here, which has multiple variables. But anyway, let's go ahead and hit refresh here. Let's see what appears. When I click on it, we're going to see that right here we have all the variables that we've just created. We've created 100 subslots, so we can see that each one is here with different values. Here, for example, we have, well, the set, the map, with its own different values. But anyway, that's it. Here, from this menu, we can modify it. All right, now going back to the example. Here we have the same thing, but with a load. If I hit 4, I'm going to load 100 times. That is the 100 subslots I have here, and I'll obviously end up with the last one. Why? Because it will be the last one in the queue. Ito, and if we look at this, it has these values 168, 4000 and change. So we'll come here, hit play, then hit 4, hit loaded. We get the display of all operations, and we see that we have 168, 4776, and so on with all the data, which are the same ones we have in this subslot. But anyway, that would be all for example 2, which is the example of how the queue works. As we see, operations are executed in the order they arrived, especially if they're synchronous, because if I were to take this out and run 99 operations synchronously, it would execute instantly, and in the order it arrived. So I still have the last one. Yeah, tipo salas yana si kaseta Y. They ran in the order they arrived, but they blocked the game thread. So, until the operation was completed, the game didn't continue. Well, that's all for the second example. Now we'll move on to the third example, which are stress tests. Alright, and for this third example, we're going to carry out some stress tests to demonstrate a little bit how the system actually behaves when facing extreme situations. For instance, here, we're going to perform the same saving operation, but we're going to save it 5,000 times. I mean, we're going to see how it behaves when we perform 5,000 saves in a loop. First, everything is obviously going to freeze up. Why? Because if I now press button 5, it will execute the 5,000 element loop. It's going to make it pause for a second, but then we'll see how the system operates. I'll press it now, and we see it start saving. It's saving now, and it saved 500 files, it saved 700, etc. And while I'm doing that, I'm going to take this opportunity to explain that the system much prefers by far that we provide it with a single file that weighs 5 megabytes rather than us providing it with 5,000 separate files, each weighing just 1 kilobyte. As we can see, saving just 5 megabytes would have taken only half a second, but saving a large number of files is going to take quite a bit of time, almost certainly a full minute, because it needs to queue them all up, and every single time it performs an operation, it must complete that operation before it can begin the next one. So, for the system, that creates it's inefficient. But anyway, that's all for the stress test. As you can see, it closes, no problem at all. I mean, that has to do with what's called the atomic save, which ensures that even if the game closes, the operation won't crash the system and also won't leave a corrupt file. Let's come here to TurboStruct save. We see it saves a 9 megabyte file. I mean, it's quite a large file that it was generating, but that's because we made 3,000 saves. And for the next part, the next start tests are a bit more heavy on the computer's resources. Why is that? Because we're going to save this thing here, which is called Ultra Inventory. What does Ultra Inventory have inside it? A bunch of arrays of what? Of this structure that inside has another bunch of arrays, and then this one with another bunch of arrays, and then this one with a bunch of data. So it's a mega structure that I'm filling here. All the data is being entered here. It's a mega structure that when we run it, it will slow down the computer because this function of loading random data into it will cause the computer to freeze. That's why I left a 5-second delay between loading and starting the save. We are going to come over to this spot and then we are going to delete all of this. Let's delete all of this. We are going to leave the folder empty and then we'll press, which button was it? Button 6, yes. Let's press 6. There it is. Everything just froze up on me there because it needs to load all the data. What's more, it can it can even crash sometimes when that happens because there's just so much information. We saw a small little spike, a small hitch there, and then the game just keeps going. And now we're going to see that in just a few seconds, the save notification will pop up right here. Let's just give it some time. Let's give it some time. There it is, Ultra Inventory Save. As you can see, the folder was created here and inside we have a 943 megabyte file. I mean, it's a huge file. It has a ton of data. In fact, if I were to move the mouse over the Ultra Inventory variable right now, my PC would crash because Unreal can't display that many variables at the same time. It would just crash my PC. So we're only to avoid doing that, and now we'll do it using Unreal's base system. We'll do the same, load data, then create a save file that holds the inventory and store it in a slot, a user index. And after that, we'll do the same thing, but with Unreal's asynchronous system. Which keys did I put it on? 7 and 8. Okay, let's hit the 7. There it goes. Well, we can see that it's done, and now in 5 seconds, the saving will begin. We're going to wait for it, and then it froze on me. Now it's doing the saving. As we see, during that, the saving process takes forever. It is true that TurboStruct takes a little bit. It might have taken 2 more seconds, but those 2 seconds passed while the game was still running. So you didn't have to wait for those 2 seconds. And we see that the file weighs 945,000 kilobytes, which is 900 megabytes. But it weighs 900 megabytes. This one also weighs 900 megabytes. I mean, they weigh the same in terms of their base weight because TurboStruct has file compression, among other things. So in terms of base form, they weigh the same. Now we're going to do it with the same system here, with this, but instead of saving in Oh, I think my engine just died. Yeah. Because as I was saying, I must have moved the mouse over the variable or something like that. And, well, Unreal decides it's time to die when... Okay, you're going to see a short break and I'm going to restart the engine. Alright, then we're back now. I've already restarted the engine, so that should be it. That's up. We're going to open this blueprint right now, and then we're going to test the last thing, which is number 8. If I do it with number 8, it's going to save it asynchronously. I'm going to delete this from here so that the file isn't present, and then we'll press 8. there it goes. It's a freezing up because it's creating the data, and now in 5 seconds it'll save asynchronously using Unreal system. As we can see, the engine just froze up hard again because even Unreal's asynchronous system, when the data gets too high, it starts to freeze. And there it appeared. 940, and I mean it'll probably be 920 something megabytes. Well, but anyway, there we have a comparison. Now we're going to do a load. I don't have a load with the base system, but we'll see that it actually saved the files. Now, when I press 9 on this structure, we're going to get a random piece of data, which is this one here. That's that data. Let's go with 9. We're selecting 9. Now it is, in fact, it's loading now. So it needs to load the file. Search, because as I said, when the file, as I mentioned before, in the other example, I mean, it's better to have many 5 megabyte files than one file, I mean, than 5,001 kilobyte files. But there it is, it gave us the information 5.0.5. Why right at the very last second did it give us a big problem? This happened because when it finishes loading, it has to copy the variable to us, meaning the data it retrieved from memory. It has to copy that into our own variable, and that is the only load process that runs on the main thread. That's why we get that little glitch, which only occurs when we work with a massive volume slot. Here we had a slot of 900 megabytes, so it had to move 900 megabytes to our variable, and the moment that process was executed, that's when we saw that little hitch that the engine had. But for the rest, all the load and save process is done off the main thread. The save makes a copy of the data and does everything externally, and the load does everything externally and gives you the copy of the data, which is why the system is super fast. And the only problem we have is that little jerk when the data is being copied from RAM to RAM, which is also an ultra fast operation. That's why, unlike the base system, which when I click, it freezes for 3 to 5 seconds, here it froze for barely anything, about 0.1 second. But anyway, that's all for the stress tests. I mean, it's not recommended to have massive files, but it's also not recommended to put 5,001 kilobyte files. For most games, files between 10 and 50 megabytes are used if they're games that save a lot of things. Here, I'm showing what happens in extreme cases, which isn't normal, but that's what happens in stress tests when we're in an extreme case. All right, then with that, we're going to wrap up the third example of this TurboStruct. So, well, we'll see you all